3.3a, we're going to look at the definition of mutually exclusive. Basically, think of it this way. It's impossible for two events or more to happen at the same time. For this class, we're just going to look at two events. So it's impossible for two events to happen at the same time. Okay, let's give an example. Let E equal the set of all even numbers. Let O equal the set of all odd numbers. Now let's check the intersection. The set E intersect the set O. Is it possible to have a number that is both even and odd? No, it's not. And so we have the empty set. All right. So since there is no such thing as a number that can be even and odd, we can say the set E and the set O are mutually exclusive. Okay, so let's look at the definition now of not mutually exclusive. Well, for two sets to be mutually exclusive, it's impossible for two events to happen at the same time. So what would not mutually exclusive mean? It would mean it's possible for two events to happen at the same time. Okay, so let's look at an example where this would occur. We're going to let Q equal the set of queens in a deck of cards. So we have the Queen of Hearts, we have the Queen of Diamonds, we have the Queen of Spades, and we have the Queen of Clubs. Well, that's funny looking clubs, but you know what I mean. Okay, we're going to let C equal all cards that are clubs. All cards that are clubs, that have clubs on the picture. Okay? All right. Can we take an intersection? Is it possible to have a queen and a club at the same time? Well, of course, we have a Queen of Clubs. So that would be the set with the Queen of Clubs in it. Okay, so is this mutually exclusive or not mutually exclusive? Because it is possible to have two events happen at the same time, we can say that Q, the set Q and the set C are not mutually exclusive. And from now on, instead of keep writing mutually exclusive, I'm going to put M.E. mutually exclusive. Okay, we have some probabilities, some little formulas for mutually exclusive and not mutually exclusive. Okay, so probability for mutually exclusive. Okay, and that would be P of A union B equals P of A plus P of B. So we add the two probabilities. Okay. Probability for not mutually exclusive is P of A union B equals probability of A plus the probability of B minus the probability of the intersection, A intersect B. Okay, now notice something. Remember I told you about where union, we talk about or, so we have or here. So when we look and see the word or, we have to ask ourselves, are these sets mutually exclusive or are these sets not mutually exclusive? And when we know if they are or not, then we can use the appropriate formula. Okay, so now let's do some work using these formulas. Okay, so first example. We're going to pick one card, just one, from a deck. Pick one card from a deck of cards, okay? Probability of a jack, well, there's 4 jacks and we have 52 cards, and that reduces to 113, okay? Probability of not a jack, well, how many cards that are not jacks are 48 cards. So we took away the jacks and we left with 48 cards out of 52. And that is 12 out of 13. Okay? Now we're going to look at the probability of a jack or a queen. Now remember here, we're picking one card. We see the word or. So we have to decide, is this mutually exclusive or not mutually exclusive? Is it impossible to get a jack and a queen at the same time when you're picking one card? Yes, it is impossible. So this is mutually exclusive. Now that we know what it is, we can use the appropriate formula, which is probability of a jack plus the probability of a queen. Jack is 4 out of 52. Queen is 4 out of 52. This equals 8 out of 52, and this reduces down to 2/13. Okay, let's look at one more. Probability of a jack or a heart. Okay, so we ask ourselves, are these two sets mutually exclusive or not mutually exclusive? Is it possible to have a jack of hearts? Well, yes, it is. So this is not mutually exclusive, and therefore we're going to use the appropriate formula for that, which is probability of jack plus the probability of getting a heart minus the probability of getting the jack of hearts, because we don't want to count the jack of hearts twice when it's in here and it's in here. Okay, so probability of a jack is 4 out of 52. Probability of a heart is 13 out of 52, and we're going to add those. And we're going to minus the probability of jack of hearts, which is 1 out of 52. And we end up with 16 out of 52. And that reduces down to 4/13.